Well, as most of you are aware that bacteria is a problem, especially Legionella nowadays. So today we will be discussing something on Legionella detection and the diagnostics. I have an important announcement that we have come up with a book which gives all you need to know about the Legionella, sampling, detection, prevention, etc. or how to develop a requirement if you have a requirement for testing the Legionella, what you will be looking for contractor, qualifying criteria. This is written in this book. You can get this book. If you don't mind, put your card on the table and my colleague will collect the card and they will promptly send you one of these free of charge, okay? So this is very good information compiled in this booklet. Having said that, let's go in the subject content. If you have any question, please hold it. We'll discuss that question because we will be having a lot of time after the presentation to discussing, and I will be around. If you have any more additional question, you can go ahead and ask me those questions. Let me start with the today's agenda. What we are going to do in this presentation, I'm going to give you an introduction about the Legionella, what it is, because many a time it is important to understand that what Legionella and what it can create in our place of residence, place of working, office place, etc. We will be also giving some important information that will justify this subject, that why it is chosen for today's discussion. Where to begin? Because I don't expect everybody in this room a full-fledged microbiologist and know all about microbe, but it is not a microbiology class either, but we are trying to give information or enough information so that you can make your judgment that whether you have need for that or not. Science behind it, because whatever we do in the laboratory, there is a science behind it. What it means that you do the same thing, more or less, you expect the same thing, and you will get the same thing. That's how the science works. And then, what to address? If you have a Legionella, what is important aspect that you should be really concerned, you should be really focused, you should be really managing. And then, how to handle the situation if some situation come where people start complaining their health, hygiene, etc., how to handle that without getting panic. First thing first, the Legionella, the name itself, come in picture 1976 during American Legion Convention, which was in Philadelphia. If you would have in this room before 1976, this was not a thing. Because in 1976, during that convention, a lot of people get sick. And you will be surprised to know that about 25 to 26 people were dead, and then CDC called on site to investigate what happened. And mostly people who were staying in the hotel get contaminated. And then it took almost 1 year to CDC to come up with the cause. And they find that the culprit was bacteria. And the name of the convention, the bacteria nowadays known as Legionella. This is an environmental bacteria. I want to give you a little information that there is a difference in the environmental bacteria and clinical bacteria, because environmental bacteria are more tough. They can take several challenges and it can born in environment itself. When I use the word environment, that include air, liquid, meaning water, or various kind of surfaces.
Good morning, everyone.
So this bacteria is naturally occurring. I'm sorry, this is.
Amazing show. Our exhibitors are waiting for your arrival, and the show is now open. Please come in and have a comfortable
Thank you. I hope that was a very loud, thing. So, well, what I was telling that it is a naturally occurring, meaning that it is not like contracted from man to man or animal to man or zoonotic type of situation, but rather it is growing everywhere. The only thing is that you need to know where it is growing, and that's why we do all these kind of exercise. This is a gram-negative bacteria. Those who are not aware about this word, simply understand that in science, we identify organism in a particular manner. Like in the human being, just being analogy given that the human race are basically of three type, Caucasian, Negroid, Mongoloid, that sort of thing. So this is a category of bacteria which falls under the gram-negative. This is a big category of bacteria. And the shape of bacteria is rod or cocoid, meaning it is going to look like some kind of a small rod or some kind of sphere. And that's why the name is being given as a rod or cocobacillus to filamentous, meaning it is a thread-like a structure. And then it is pathogenic as well as nosocomial. Nosocomial meaning that you can acquire the infection in hospital. When you admitted for one issue and you get infected with something else due to the bacteria or other pathogenic agent, that is called as nosocomial. It can create some issue health-wise. The very first thing and very popular one is the Legionella disease, which is a pneumonia-like symptom giving to the human being. Pontiac fever, this is also sort of pneumonia, but it is less intensive. Still you have a fever, mild headache, etc. Then this also create trouble with the upper respiratory system, and that is extrapulmonary syndrome. About 8,000 to 18,000 Legionella disease is reported in America each year. And out of this number, you will be very surprised, it is growing very rapidly. As you can see, I have given one information that it has grown up to 4 times during past 15 years or so. And then the rate of fatality is 10 to 15%, which is a big number. So a lot of people die with that, and this stat has been compiled, which comes in the light, who is being reported by the hospital or the patient. There are several other cases which we have no clue, neither we know about it because it is being not reported. So, why prevention is necessary? It has 2 aspects. One is the environmental exposure aspect, how you get exposure to the bacteria by drinking contaminated water, by coming in touch with the contaminated soil, or breathing the contaminated air. We'll give a little bit more information on that later during the presentation. What are the health implications and who is more prone to acquire these kind of infection? The immunocompromised individuals are the top one who are more vulnerable and at a greater risk than others. The age group 50 years or above, because their immunity start going down, so they are also more vulnerable. Then commonly, it is in the community in terms of outbreak. One person get it and then contaminated water in that community, then other fellow start consuming the same water. So it is become like a sort of outbreak or epidemic. The individual having the smoking habit is more prone. And people with lung disease such as COPD are also very vulnerable to acquire this infection. So where is Legionella in nature? In a minute ago, I was telling you that it is in the nature. So as you can see, you can get this bacteria in soil, in river, in lakes, and other water bodies. Man-made environments such as building water system, water storage system, pond, decorative fountains, whirlpool, misters. You go in Disney during the summertime, they are misting the water to keep the environment cool. But guess what? If that water is not properly maintained, or the mister system itself is not properly maintained, then that can be a big reservoir, meaning is a big number of Legionella can be there and continuously misting, and you can inhale that and you can become the victim of that. What is the favorable condition for this bacteria? The favorable condition, first of all, is the temperature. This is a very unique bacteria because it's like little higher temperature and it can survive in a greater temperature. Typically, bacteria are very sensitive towards the temperature, and a lot of bacteria is not capable of tolerating the higher range of the temperature. So the 35 degrees Celsius to 42 degrees Celsius, which is about like, in terms of Fahrenheit, is going to be above sometime 100 degree Fahrenheit. So it's a lot of temperature this bacteria can survive. And then the deferred maintenance is number one cause, and unfortunately you all are in the facility. The very first thing building owner cut when the belts are tight is the maintenance, because they think that we can get by with that. But that is one of the main reasons identified because of the deferred maintenance and number of issues create. This is not a proper class to talk about, but there are an issue. I can just tell you that how it supports these kind of contamination. And basically deferred maintenance, where you are going to defer in the plumbing system, because oh, water is coming, life is good, don't care like what is the scaling or whatever. And then the HVAC, like air conditioning system. Then your water mister, as I was telling you, that is okay, you on in the morning, it works all day and switch off in the night. So that these are the system where we just out of sight, out of mind kind of thing, that where this bacteria harbor. Then the biofilm, I'm not sure how many in this room understand the biofilm, but the biofilm is basically nothing you have seen in your practical day-to-day life, like a mucus slimy membrane, like sometimes it appears like little brown, or it's like a papery thing near the water source or on the building material such as drywall or sheet rock. So those are the biofilm that is being composed of a number of bacteria and other microbial things such as protozoa, mold, etc. That makes the biofilm with organic and inorganic mixtures of chemical. Then the nutrition for this bacteria doesn't require a lot of thing. All it requires a little bit of organic matter and sugar, and the bacteria is good to grow. Other conditions such as you take the contaminated soil, such as potting soil, and you kind of start potting, and nowadays a lot of people just do indoor planting for beautification and other architectural purposes. That can also spread this bacteria, and that's a favorable condition because bacteria gets a cozy condition to grow because it doesn't have to exert a lot to grow. What factor influence that? The number one factor which can influence is the pH level, because I'm not sure how many you understand the pH, but pH is a measurement or a scale which tells you that how much acidic media or basic media you are dealing with. Water has 7 pH, that is called as neutral, neither it is acidic nor it is basic. So some bacteria can grow only in acidic, some bacteria can grow only the basic, but this bacteria has a greater tolerance, meaning it can tolerate the acidic zone as well as the basic zone. And then the biofilm, as I was telling you, that in the biofilm, the organisms, the microbes especially, live in the symbiotic condition, meaning they can help each other. So that is also an influential factor for growing the bacteria. The chlorine residue in the water, if you have enough chlorine available in the water system, then more often than not, bacteria is not going to grow that easy. But if the chlorine or chlorinated or treatment is being not done, then the bacteria have easy condition to grow. So how to respond? Like I was telling, because many a time people think that, oh, there is an epidemic, like people are going to die, is this, is that, and people become panic. But as a facility manager, you should not be getting any panic, because if there is a problem, there is a solution. So what you do, how you manage the whole scenario, basically there are two things you can do about it. The first one is the proactive measure, what we call, and the other one the reactive. As the name itself telling you, the proactive, the steps or things you do before even the problem arise, or try to make every effort that the problem should not be there. So what are those proactive measures? Basically, do a quarterly, half-yearly or yearly monitor, meaning periodical monitoring of bacteria for their presence or absence, whether you have Legionella or you don't have Legionella. Then you can make a WMP, that is water management plan, and I will tell you a little bit more on the water management plan. It is an integrated approach to maintain the man-made water systems, such as building water system. And then you should have a better understanding that if you have the infection or you have the contamination of that bacteria, what would be your steps. So you make your understanding that we are not going to be in the panic mode, we are not going to be in any kind of miscommunication among the occupants or residents, but we are going to take it seriously and we are going to manage it appropriately so it should not create any trouble. Reactive, what if it happens, you were not aware, you haven't done any preventive maintenance, you haven't taken any step for proactive measure, then bacteria just flourish. So how to respond that? Again, the very first thing to know whether the bacteria is really there or not, because the symptom caused by this bacteria is non-specific. It could be something else, but it is mimicking that Legionella. So again, the rule of thumb, confirm the organism. Remember, not all the Legionella is going to be deadly pathogenic or pathogenic event, because some specific genus of Legionella is a concern, such as Legionella pneumophila serogroup 1. This is a name of bacteria which I just said you, that laboratory confirms. That's the one of the concern. But there are a number of other species of Legionella that might not have a concern so far human health is concerned. Responding to the cluster or outbreak, meaning that you should be reaching or try to make your every effort to reach those community where the cluster or outbreak of Legionella is confirmed by the medical professionals. Okay, this is that. Then the role of environmental scientists like us kicked in, so that we can guide the facility manager that you should be doing this in order to manage such and such a step, so that you should either minimize or altogether eliminate the problem. And then the investigation of source and cause, like what has created the whole problem. I'm pretty sure you have gotten some news recently within a couple of years or so, some very pronounced Legionella outbreak in our country. In Michigan, there is a place called as Flint. I'm pretty sure that you are aware of that. In Flint, there was a Legionella epidemic not too long ago. Still, it is under investigation, but initial investigation reveals that the water contaminated with Legionella was taken from the river and was supplied to the resident, and that was one of the primary reasons. Still, the cause is under investigation. So see, this is the source-cause relationship, like where the Legionella come and what it has done. So now, the health professionals and other environmental engineers and plumbers and everybody is involved to make sure that you are taking the water from a cleaner source, and that require and that call for the testing, make sure that the bacteria is not contaminated in the water which you are going to get for public use. So that one example. Bronx, New York. Again, in that case, initial investigation reveals that the Legionella was contaminated in the storage tank and is still under the investigation, but it has cost us with like 13 to 17 lives. So that's a big loss. I wanted to give you a little story so that you can understand what is the importance of source and cause, because if you know the source, then obviously it is easier to manage. If you don't know the source, what you will be doing. And then the Legionella surveillance program. Anytime if there is a Legionella issue in the facility or the facility which you are looking at, it's a good idea to have a surveillance program in place. If your budget is not permitting to do a periodical checkup, bi-monthly, quarterly, half-yearly, yearly, you can always do a surveillance program. Once in a while, you can check, I wonder what is the water quality. You do water quality. Likewise, you can also think yourself that I wonder whether Legionella is there or not. And a simple laboratory test can give you ease of mind and give you for certainty that there is a problem or no problem. Get organized, because if you are not making your homework, then don't complain afterward because you missed that, you missed that. So that's why it is always a good idea to notice that what are the risks and hazard of the building. If it is known by history or experience, or a building is new, then look for those factors that can influence. Like I was telling you that potting plant, you have a brand new building, there is no Legionella issue, brand new water system, but you have a potted plant with the soil contaminated with Legionella, that can be issue because subsequently it is going to find the way to get in the water system and create those kind of problems. So do the hazard analysis. Identify the building water system, like where you are taking the water, what is the intake, how you are taking the water. Many a time, the municipal water or the water company supply you the water. So your first check and balance is that where you are receiving the water, that place is clean or not, lot of dust is on the pipe or not, etc. Those kind of analysis need to be done. And then you should be, like I was telling you, collect water sample time to time and check for Legionella, whether you have Legionella or not. And if you have a Legionella, then you should have also written procedure or written document what you do as a control measure, which I will be giving some hint during this presentation. So risk and hazard condition, like I was telling you, that it required the motivation, it required the factor which is responsible for creating risk and hazard. Documentation is must, because many a time people work one place and they leave that place. So but when you leave this place, make sure you have a documentation of everything, so the person who is going to take over has some background and he can build on that. Many a time I see that thing lacking, because okay, I was the building manager of that building, I have a better opportunity, I move, but the person who is coming in has no clue that what condition this thing. So documentation is one of the thing. You develop hypothesis that if you happen, you do this, that sort of thing, and you prove your hypothesis with like laboratory testing, environmental hygiene practice, etc. And then take appropriate action. Just do not say, oh, I have made document, life is good. But no, you act on that. Like, whatever document you did, what you say, you do. What you do, you say. The building water system, I wanted to give a little bit of information in that. Like as I was talking, in this diagram, you can see I have said or identified some of the important point or the pressing point or the tipping point, which is very important for Legionella, such as point of entry, I was telling you. Then the water distribution system, how the water is being distributed, whether it is the water is used for drinking purposes, water is used for the laundry purposes, water is used for the irrigation purposes. So you identify that, because everything has its own advantage and limitations. And then the source of water, whether it is a well water coming just directly from the ground, it is a potable water supplied by water company, so you can check like where they are storing the water, what are the storage condition, etc. And then water condition, whether hot or cold. As I was telling you that the hot water is more prone because it supports the Legionella growth, and that's why this bacteria is a little bit different than other bacteria, because it can tolerate the higher temperature. So it is very important to know that. And then the pattern of water discharge, because once you use the water, how it is being disposed, that is also a very good point to be noticed, because the effluents is going to contain like a lot of thing, and maybe this bacteria have more organic matter or rich organic matter there they can flourish well. This is a very important segment of my presentation. It tells you something about the sample collection, the water sample collection. Each day in the laboratory, I get a number of calls from various folks that how to collect the water. The very first and simple way to collect the water, that is the potable water from the point of use, what we call POU. So what you do in the point of use, using the aseptic condition. When I use the word aseptic condition, meaning it should be clean. Just understand that like you should have a minimum PPE. I will tell you what those PPEs are. And then you take a sample collection bottles, and that is called as sometimes water sample collection bottle, which you can see here. It's a polypropylene made material which is sterilized in the laboratory and supplied to the place where they want to collect. So you take that water. We require, if it is a potable source, we require somewhere 250 ml to 1000 ml of water. Simply flush for a few minutes or so, take the water, desired amount, which is 1 ml to 250 ml in that bottle, and they screw tight that bottle. And if it is recently treated, then you have to put something we call as a stabilizer, which I have given information right here, which is like about 0.1 N sodium thiosulfate. That's a stabilizer that preserves the bacteria so that we get you the right result, because it is a microbial thing and you collect, it still keep growing because it's bacteria, it's alive. So that's a stabilizer, so do not forget that. But it is encouraged when it is only treated with like the water is recently treated. Now the non-portable source such as cooling tower, etc. This particular incident is like telling you how to collect the water from the HVAC, heating, ventilation, air conditioning system. Many a time you have a drain pan. In the drain pan, the water drips out due to the condensation, and there is enough water in the pan. So you can collect the water directly from the pan, or you can put that bottle, like a sampling bottle, and let the water drip it. And like, in this case, even a smaller volume, like, up to 100 ml volume will suffice. If it is not there, then I will tell you the other method to collect the water sample. Again, the exercise is the same. You have to be still like, considering the sodium thiosulfate if there is a recent issue of treatment in the water system. Even though it is an air conditioning system, but it still be encouraged, because what happened, the water which is going through the building water maybe evaporate and condense by this, so it might be having that residual chlorine. So that's why it is encouraged to do that. Then the other sources such as pond, fountains, spa, etc. You just simply draw the water. You see in the picture that how we are drawing the water. Draw the water, again seal it. Like 1 liter of water is going to solve the purpose. 1 liter is 100 ml, and typically in terms of pound it is tentatively couple of pound, because water density is 1. So like 2 pound is about a kilo. So that is like 900 some ml. So that should be good. Remember, I was telling you where either the water sampling is not possible or you don't want to test the water, you can collect the swab sample. How to collect the swab sample? Basically, there is a specific type of swab you have to order from the laboratory. Again, I want to underscore, do not use the cotton tip swab, because many people are like, using cotton tip swab, which is not really good idea, because cotton is supporting factor for the bacteria, first thing. Second thing is that there is a lot of like, proliferation within the, cotton tip, because it can hold temperature and stuff, and that will be like, skewing the result. So you use this polypropylene made swab, and you just like, back and forth stroking around the surface which you are trying to collect, and just put the swab back in their container and send it to the laboratory. That's how you should be collecting the swab sample. The biofilm sample, as you can see, we can use a swab again, but the biofilm, where to find the biofilm? So one very common place where can get the biofilm is that where the faucet is being screwed with the water supply pipe. If you just unscrew the faucet, and if there is you see like in this picture the surrounding periphery gluey mass, that's the good biofilm to be collected. So you can use a swab to just roll over by making the vertical and horizontal stroke that biofilm and load the biofilm on the swab, send it to the laboratory. Make sure that you do a 1 or 2 drop of distilled water or sterilized water to keep it moist so that the biofilm doesn't get dry. Air sample, this is a little bit technique involved. What is the technique? Technique is being that we use typically a process called as bioaerosol sampling, in which what happens, you have a vacuum pump which sucks the air with a known quantity, and then the suck air being spread over a microbiological medium. For Legionella BCYE, that's the name of the microbiological media, buffer, yeast, agar, charcoal. So that media is basically good for the growth of Legionella. So you can take the air, pass over that, and then you put this culture in the laboratory. Once it grows, then you can identify. Thing to be noticed, the Legionella bacteria typically not airborne, and it required like a longer volume to be sampled. If because bacterial inoculum is there, their quantity is very less. That's a good thing. Sample transportation, many times in the laboratory I get this question all day long, that how to send the sample to the laboratory. Rule of thumb, without going in fancy grancy, rule of thumb is that use the room temperature. As long as you are using the room temperature and not exposing in the excessive heat and cold and the light, your sample should be good. But as a matter of fact, you should be using a thermal protector, which you can see in this diagram. And then you can also use some ice pack to keep the temperature cool if it is really a hot situation, or even in case of freezing temperature, you can use this thermocol temperature, what you call resistant container, that can preserve your sample good. One thing I want to emphasize, I have said during the sample collection that how you should be collecting the sample, but here let me emphasize that every sample should be properly marked or uniquely identified. Because if you don't identify the sample properly or uniquely, then you will have hard time to get the result back and to correlate. So it is very essential that you should be identifying those things very uniquely and very properly by using a document called as chain of custody. The chain of custody is also the legal proof that who has handled the sample from its collection to analysis. So every step somebody is handling the sample, and that can be documented in chain of custody. In the laboratory, the samples, quite frankly, is being tested in 2 or nowadays 3 manner. The first one is the non-culture manner. The advantage of this manner is that it is fast. You will be able to get your result as quickly as same day, within few hours. But the limitation of this method is that you may not be able to get exact speciation or exact organism identification which is responsible for Legionella. But there are certain techniques such as direct fluorescence. This is a technique which we use in the laboratory. It gives a special lighting. If we reflect some UV or bombard some UV on the bacteria or the specimen, that it glow, put it like that, under the microscope, and that's how I identify, or that's why this method is very, very quick. And then antibody test, we have several commercial media available which is having an antibody which kind of bind with the antigen of Legionella, and that's how we figure it out that okay, there is a Legionella in this specimen. Then Antigen identification is somewhat specific, and it is possible to identify the organisms. And as I said you, these are the rapid method of testing. The gold standard is culture method though, because you culture the organism in the laboratory, and then you identify by recovering it from the specimen. How you recover it, there is a number of laboratory process. Due to the time paucity, I am not giving every step. But as I said you that there are some specific media. If the organism is growing on those media, then we proceed for a confirmatory test, which is a special character of this bacteria that it agglutinate. If I put some chemical there, it gives agglutinate, meaning that it coagulate that chemical, and that's how we identify in the laboratory that this is like the Legionella. The greatest limitation of this method that it is time consuming, because we cannot make bacteria like growing fast. Then this is the most recent technique, and unfortunately there are not much laboratory, or there aren't many laboratory in the country that as a start doing it. But good news is that we have it, we do it. We have indoor PCR, that's the machine which handles that. And what it does, it amplifies the DNA. DNA is the molecule of life, so it is very specific with every individual. So we identify those bacteria based on their DNA configuration by using a technique called as PCR, that is polymerase chain reaction. It is a molecular diagnostic because this is not based on the morphology, it is based on the genetic makeup of the organism. That's why we call it molecular diagnostic. And result is very fast. It can be done within 4 to 5 hours typically, if everything is in line. So you can expect the result same day in this. Result interpretation. There are two methods to interpret the result. The first method is the qualitative method. In this method, you can say yes and no, whether Legionella is present or Legionella is absent. That's about it. That's the extent of the method. But the quantitative method can tell you how much is that, like whether it is 1 colony forming, 5 colony forming. These are the unit or scaling, so that a person who manages health and hygiene can understand, or industrial hygienist can understand that what is the density of the problem or how severe is the problem. The prevention is one of the things which I discuss. I encourage everyone to go through this ASHRAE guideline on Legionella risk management for the building water system. This is a very good comprehensive standard to maintaining Legionella in water system. Some bullet point or focus of these standard was not existing before May 27, 2015. So it just like the whole gamut of this standard start really in discussion 2015, and now we are in 2017. So it is a very recent, and when you have something recent, then there is a lot of things is being incorporated. So I really encourage you to go through this manual, and this is also, by the way, adopted as a standard by the ASHRAE committees. So the core element, I'm just giving you a real quick dirty view of this. The core element of this whole standard talks about the compliance, which is described in section 4, and it exclusively talks for building designer, building owner, and the healthcare facility. So these are the three different segments. Especially they have focused and they have emphasized the healthcare facility, how you should be maintaining. They have also discussed in detail section 5 about the building survey, that what you need to know about your building. General requirement, what should be the general consideration to prevent Legionella is described in section 6. Requirement for the building water system, when you are designing the building water system, what should be the requirement, what should be the thrust area, that is described in section 7. I'm sorry, I'm just giving you the bullet points because every section has big discussion. So this time is not enough to describe everything. So I'm just giving you the bullet points. And then the requirement of designing building water system itself is a section where it gives you that what is appropriate to design the water building system. And this talks in the section 8, I believe. Now, many times people ask me that how good is good, how bad is bad. There is no direct answer for that, but we have some idea and some information available in both public and non-public domain. That is one of those is OSHA clearance guideline. OSHA clearance guideline talks about the domestic hot warm water for the Legionella of the following schedule should be maintained for testing. What you do weekly for the first month after if the Legionella issue is being like known or is being recurring. So then you start doing it like weekly testing. If it is that, then if you are not getting like lot of like Legionella, then it can be go every 2 weeks for next 2 months, and finally a month for the next 3 months to make sure that the Legionella thing is being completely addressed. Then there is action level. The action level 1 and 2, you can see this, that if in the cooling tower evaporator condenser, if you have a 100 colony forming unit that forms in the action level 1, action level 1 call for cleaning followed by the biocide treatment of the water system if appropriate. Action level 2 is call for the cleaning followed by the biocide treatment and take immediate step to prevent employee exposure, meaning that if Legionella is known, not let the employee like exposed to that. And then the potable water, these number are 10 for the level 1 or action level 1 and 100 for the action level 2. Humidifier mister, 1 colony forming unit for action level 1 and action level 2 is 10. This is another standard by which you can find whether the Legionella is in the water system or not. This is the method which we call indirect method, that you measure the other bacteria such as heterotrophic bacteria. Depending upon the concentration of the heterotrophic bacteria, you can see that whether you are vulnerable or not, whether the Legionella is going to grow in that environment or not. If your heterotrophic count is like less than 10,000 colony forming unit, then the control is acceptable and life is good. But if it is like more, then you have to be like doing appropriate actions. This is the another one which is in terms of like cooling tower Legionella counts, and as you can see that if it is 0 to 10 colony forming unit, you see the actions what you're supposed to do A, B, C, D, and that is increase biocide review program, retest until like less than 10 colony forming unit, disinfect and clear the whole thing, clean the whole thing within 30 days. If it is action level C, action level D, call for the disinfect and clean within 7 days, review program whether it is good or not, or it is effective or not. Then the disinfection, how you do the disinfection, selection of the disinfectant is one of the greatest criteria need to be assessed, and the disinfectant can be chemical, physical, and environmental. When we do chemical, mostly like chlorine, people treat the water with chlorine. There are some physical like the copper and silver ion like treatment, and then physical such as or environmental such as temperature like treating with the higher temperature, etc. And then obviously the efficacy monitoring and emergency disinfection is that you normally or typically enhance the dose. This is the preventive action. As I was telling you earlier, that the maintenance of the plumbing system, routine checkup of water source, avoid stagnancy of water. That's the main thing you should be considering. Water temperature monitoring is going to tell you a lot for Legionella prevention. And corrective action is the replace discard Legionella contaminated material, infection or infected equipments as a biohazard. Just do not start like taking those material and start like throwing here and there. Must be properly discharged like a biohazard. And treat the infection water with the disinfectant, which I had just said. Here, the forum is open for the question and answer. If you have any question, I can go ahead and share my opinion on those questions. And I hope you have chance to get some information on Legionella. As I said, this is a real nice practical handbook. you have to put your card on the table, and my office will promptly mail a copy to you. And again, thank you very much for your time. And if you have any question, go ahead and ask the question.